All right, cool. Welcome. It's good to see you face to face again after quite a long time, at least for me. So welcome to Pyvo. Thanks for coming. We have two speakers today. One from Kiwi, one from Nick, right? CZ.
I don't know how to pronounce it in English.
You know the company. Today Pyvo is Asynchronous. Both speakers will be talking about Async.io, I guess. And the first one is Max from Kiwi, and they'll tell you something about health and monitoring with Async.io. Thank you.
Hi guys.
Hey.
So I'm Max. Today I want to talk about health of Async.io apps. So I was told it will be a dedicated async Python meetup, right? And also I was told that it will be in some bar with some beer. So I applied instantly. Okay, so about me, started to code something about 19 years ago. Yeah, I'm so old. 8 years ago started to get paid for it and became happier. Now is a senior software engineer and working for Kiwi.com in Prague. So, what is Kiwi.com? Maybe you heard about this company. If not, so Kiwi.com is a service to find cheap travel options, mainly flight tickets, and not only to find them but also to buy them, to have some support directly from the company. So Kiwi.com will take care of all of your problems with your flights, and so great service. So how many engineers are needed to develop such a service? Apparently more than 400, and I'm one of them. We use Python, Go, so quite a modern stack, so there are many cool words here. And what's most important, we use Python a lot, and we use Async.io a lot. So we have some experience, and I wanted to share our experience with you today. Async.io. What is Async.io? By the way, does anyone use Async.io? Raise your hands. Oh, okay, okay. Does anyone use Python? Oh, better, okay. Okay, so Async.io. It's a very nice. Oh, where's my presentation? Yeah. Okay, Async.io, very good choice if you need to handle many input-output bound tasks and have it in a scalable way. It scales really well. It can be simpler than, for example, when you try to solve same things, same problems with threading or multiprocessing in Python. So usually Async.io implementation can be a bit simpler. And it's kind of a standard way of writing concurrent code in Python these days. But unfortunately, with all these advantages, Async.io brings some problems. So, problems of Async.io, yeah, so many of them, so this guy is so sad about it. There are actually two, let's say, groups of these problems. First is about cooperative multitasking itself. So Async.io is a cooperative multitasking. We have preemptive multitasking and cooperative multitasking. So these problems are related to cooperative multitasking, and then on top of these problems we have problems with Async.io itself, with how it's actually implemented. And what to do with all those problems? I will try to briefly go through all of them and give some advices what to do with them. In general, what can be done? We can test our concurrent code. It's possible. We should be careful when we programming using async I/O. We should keep in mind all those problems. We should know how to solve them, how to avoid some complex cases, and we can monitor our async I/O services. Mainly, we can monitor the event loop. I will show how we can do it. Tests. Sometimes it's difficult to test concurrent code because we have many tasks running concurrently, but usually it's unpredictable in which order tasks will be, how execution will switch between the tasks. But luckily we can actually have control over this order. And here is an example of how we can control it. We can use async I/O events. So we can wait for an event in the coroutine, and then set the event when we need to switch to that task, and this way we will have control over the order, how the tasks are executed. So if you need to test some complex cases in async I/O, when the order of tasks of how they are actually executed matters, then you can use this technique and probably it will help you. But such tests are usually complex, difficult to maintain, but sometimes it's the only way to actually test async code. One of the main problems of async programming in general, it's blocking code. If we have some functions, some blocking functions that are called from inside our async code, we should be very careful about it. Usually it's always better to execute such functions in a separate thread, so to avoid blocking of the event loop. If it's just some blocking I/O, we can use a separate thread, but if it's some CPU intensive tasks, then we can start a separate process. Again, to avoid blocking of the event loop. If we block the event loop, then all other tasks will be also blocked, and our service will not respond to any requests and will just hang. Spawning new tasks. So it's much more cheap operation compared, for example, to threads, to processes, but it's still not for free. So we cannot just spawn new tasks without any limitation. We must have some control. So we need to limit the number of created tasks, and here is an example of how we can do it. For example, if the number of tasks that we are going to create depends on some input parameters, I don't know, some parameters of the request or whatever, then we can spawn tasks in batches and wait for a batch to run and then to start a new batch. In this way, the number will be limited. Performance of this approach, of course, is also limited. So for some high numbers of tasks, it will not be that fast. But anyway, at least it will not eat all of the memory. Then timeouts. When we spawn async IO task, we should take care of the timeout. Usually, even libraries, third-party packages that we use, they already have some built-in timeouts, but sometimes they are not suitable for our needs. So it's better to know default timeouts used by third-party libraries, packages, and if they are not good for your use case, then set your own timeouts. Atomic operations. If an async IO task is scheduled for its execution, it doesn't mean it will be completed, because it can be cancelled actually after it is executed. For example, if a client disconnected from your server, then most probably all tasks scheduled while serving that client, they will be cancelled. And in some cases, we actually want such tasks to be completed. And in this case, we can use async IO shield. This will actually wait for tasks to complete and will ensure task completion. And one of my favorite ones, tasks without references can be garbage collected. If you create async IO task this way without assigning a reference to some of variables, then suddenly during the execution of the task or even before it actually started to run, it can be garbage collected by Python garbage collector. So have a reference to your task and await for it. Or it can be garbage collected and you will never get a result of this task. And it becomes especially a problem in case of fire and forget tasks, when you just schedule execution of a task and don't care about its result. You just need it to run, to make something, but the result is not needed. Usually in such cases we don't need a reference to a task because we don't use the result of the task, and that's the problem, as I just explained. We can use something like this. As you see, something complicated is happening here, but such manual handling of such fire and forget tasks, it's complex, and generally we shouldn't do it manually ourselves. Better to use IO jobs. It's a very nice library that will take care of such kind of tasks for you, and not only about fire and forget tasks, but also about concurrency control, as we just discussed, and about atomic operations. So nice library. Check it if you don't use it, maybe will be useful for you. And finally, we can monitor the event loop. This is what we actually do with our services. We can monitor event loop log and number of active tasks in the event loop. And if something is going wrong, as we see here, then we definitely have some problems. For example, if we see a high event loop log, then probably there is some blocking operation in our async code, and we need to check it, to find it, and to remove it. And the number of active tasks, if we don't have any limit, as we just also discussed, then sometimes we can have too many tasks running in the event loop. Here it's not that many actually, but without any control at all, it can be something really, it can be really a lot here. So that's it. That's what we can do. to monitor it, we actually have our own implementation, and it's relatively simple thing. I think if you want something similar, you can implement it yourself. It's something about 20 lines of code. But 20 lines of code is still too much for this slide, so I'm sorry, it's not here. So that's it. Any questions?
Sure.
Yes, please.
So with the event blue black, is that like how long the tasks are waiting in the queue, or what is it supposed to be? You mentioned like 2 slides back, right? Event blue black. Oh, 1 slide back. Sorry.
Event blue black. Oh yeah, sure. I should explain. So yes, basically it's delay between let's say it's how often event loop switches to the same task. Yeah, if we have many tasks in the event loop, or if we have some blocking tasks or slow tasks, then to the same task, event loop will switch much later than if we had less tasks, or if we had no blocking tasks. So yeah, it's how often the event loop switches to the same task.
I can add one more.
Yeah, please.
Do you think it's worth it to rewrite like all synchronous Python services to async IO rather than like Go, for example, because that has much nicer concurrency?
Yes, in Go it's actually nicer how it's done in Go. If you have some developers who know Go, yeah, then probably you can this approach, and especially if you have some high load for your service, then yeah, you can do it. But if you have only Python developers,
well, I suppose they can learn Go then. Right?
well, using 2 languages at the same time. But yeah, of course, can do. Yes, please.
You've got the monitoring automated, and I may have not noticed, but what kind of automated responses do you have set up to anomalous behavior like this?
We monitor it with Datadog. So we have implementation of gathering of this data in our services, and we periodically send this data to Datadog, and this is how it works in our case.
Because what I'm wondering about is, like, if you got something like, you know, what you got on the right side of the slide,
Mhm.
one with a frowny,
This.
scared face.
Yep.
Like, what happens next? Like, what is the system supposed to? How is the system supposed to deal with that sort of thing? And, you know, does it do it by itself, and how does it?
In some cases, for example, if we have too many active tasks in the event loop, yeah, we can just wait, and after some time they will be all completed.
Oh,
But it depends on actually how many of them.
okay, so, yeah.
In some cases it can just run out of memory, and that's it. So the service will be restarted, all tasks will be of course killed, and yeah, this is how it can be solved by itself, by restarting a service after running out of memory.
Did you encounter any major issues while using Async.io, let's say, compared to threads, or it was very smooth sail?
Oh, yes, of course we had some issues with Async.io, especially with blocking operations when we got our service just blocked on it, and it wasn't able to respond to any clients, and it was quite difficult to find what actually blocks the service. So we should be, as I said, we should be careful when we use this approach with async I/O. But compared to threading and to multiprocessing, I would say it's still a simpler approach.
Is there any usual remedy for such issues, like turn it off and on again?
If you if it's nothing critical for your service to turn it off and on, then yes, and generally your service should be like this, so it should be safe to turn it off and on. So I think yes. Yes, please.
You mentioned in the beginning that we have to carefully handle exceptions in coroutines. In my experience, main problem with exceptions is when you have to run several coroutines and gather results, and one of them raises an exception. Maybe you have some tricks like how you handle these cases, or maybe you have something interesting in this area to share.
If we gather results of some group of coroutines, then we can use a special keyword argument, return exceptions, if I'm not mistaken.
Yes.
So it will return exceptions as task results, and then you need to go through all tasks results and check for exceptions there. So yes, this is how it can be done. Also, there is another option. Instead of gather, we can use how it's called, like wait for, if I'm not mistaken.
You want wait because wait for is, I think, for a single coroutine, and wait should be for like a list of those. So it's probably wait. If you want to
For a single task, it's wait.
No, there is something similar to gather. So it's an iterator that returns results of tasks as they are completed. Don't remember the name exactly, but yeah, there is such a thing, and also there should be some improvements in upcoming versions of Python for this, for exception handling in groups of tasks. So hopefully we will have new solutions for these problems. Yes, yes.
One more tiny question. Did you consider using some other Async.io is a default one, built-in framework,
Yes.
Library for asynchronous programming in Python, but it's not the only one that utilizes async and await keywords. Did you consider others?
We don't use other frameworks in Kiwi.com, so we have Async.io services.
Okay.
Okay. Any other questions?
Is there
Yes.
some way to combine that with multiprocessing?
We can use multiprocessing to execute some CPU-intensive tasks from inside of our async code. So if we need to execute something CPU-intensive, it's better to execute it in a separate process. But if you mean to use multiprocessing somehow for scaling, right? That's what you mean.
I mean, combine it with asynchronous loop.
In each process there should be its own event loop, actually. So yeah, you can have many running processes, and you can have event loop in each of them. So it should work. But generally we shouldn't have more than one event loop in one process. Sorry?
I don't know how it is pronounced. Global interpreted look.
Ah, yes, yes.
So it is impossible to run more processes in multiprocessor
Oh.
in one interpret.
Yeah, but that log, it works only inside one process actually. If you start another process, it will have its own log.
So it needs to start multiple interpreter, multiple processor, and each process starts asynchronous. That's only way how to do that.
Yes, but most probably you can have just separate instance of your whole service. Just not starting processes from inside of your main process of your server. Just have a completely separate instance of your service, and I think it's simpler.
Okay, thank you.
Yeah, given what I've heard about, how you resolve if something, goes wrong, you're containerizing this, right?
Yeah, it actually works nicely with containerized applications, so you can just kill a container and
Yeah.
start another one. Yeah.
Cool. Do we have any more questions? Thank you very much. Would you like to have a break before the next talk? 5 minutes before drink?
7.
Yes, please.
All right. Right, folks? May I have your attention? May I have your attention? Thank you. Okay, so the next speaker is Kuba Ružička from CZNIC. He will be also talking about Async.io, and that's all I know, so, well, it's yours, man.
Okay, hello. So actually, I want to... Hello. So I won't be talking as much as about Async.io. Partially yes, but I will be simply talking about what I was working with, and for me it's a small change, but it's a big difference. So I will be talking about a small like topic you can meet when you're programming in Python, and I for one am a packager, so I do packages. I'm a Debian maintainer and I'm a Fedora contributor, so I do packages for things, and also DevOps, so I do all the automations. For me, Python is basically a glue to glue together different things. It's not like a system programming language or whatnot. It's just a thing to glue things together. So I've been using Python since Python 2.4. I've been packaging libraries when the switch to Python 3 happened, and it was horrible. Like, you don't want to ever like live through the nightmare that the switch from Python to... So I know, you know, I meet like the results of other people's mistakes, especially how they write software. So for what I do, I write a package. It's like a new fancy state-of-the-art cross-distro packaging automation tool that basically does simple thing. You have your open source project, right? It lives in a Git repo, right? I hope so. No one's using SVN, right? So you have your repo, and when you do things, you just do build. So you call something and you got build software, and suddenly you want to do a package, and it's so much work. So a package, what it does, you call a package build, and it does everything. It builds the package from sources, and it works on Debian, it works on Fedora, it works on Arch, it can even build Nix packages, which I don't know how, because it's someone else's contribution. But hey, as long as it works. So, long story short, what I need is to invoke system-specific tools. So there is no Python library for it, like for everything. There are people who say that there is Python library for everything, and mostly they're correct. But for this, there is no Python library. And actually, I even manually invoke Git. I don't use any Git wrapper, because I do that all the time in the terminal, and I want to do it the same. I don't want a wrapper or another kind of bullshit. So I use this tool manually. So all the logic is Python, and then I need to run processes, right? So these are command line tools that I need to run, such as dpackage or rpm build. And those are long-running processes. And when you are running, and a package itself is a command line tool. So you run it from a command line interactively, or you run it from a CI. Either way, you want to see output. You want to see the logs, what happened, how it failed, why it's all broken. So for that, you actually need to see the output, yes? So, and now, this leads to, for Python, big problem. I actually need to run a process and then have access to its standard output and its error output. At the same time, I want to capture it and print it. This is what Unix command T does for approximately 30 plus years. And in Python, with the advent of Async.io, we can do it now. So that's what I will be talking now. No, not this button. So I will now go through the ways to actually do this very basic simple thing to call processes from Python. And actually before a package I was writing for Red Hat, it was called RDO package. It was for RDO, the OpenStack distribution. So it was RPM specific, it was for one platform. This is like generalization of my previous tool. So I'm spending like 8 years to actually writing a packaging tool. So I started with old Python when this didn't exist. The first implementation of a package is using subprocess popen. This is like this was introduced in Python 3.0, and with Python 3.3 you can actually use it. This is the origin. Like there are no issues, because when new feature is introduced in Python, it takes at least 1 to 3 next minor versions. So before you can actually use it. If anyone of you used Pathlib, do you use Path? Python Path? Yes. Yeah, so when it was released, it was unusable because none of the libraries, other ones like OS, SH, all these libraries that interact with it didn't support the path, so when you call them, it broke. So that took 2 releases. So for this, it took 3 minor releases of Python to actually be usable. This little, I don't know if you can even see the code. because I'm kind of blind, and when I sit there, I didn't see the code before, so I don't know. Can you see any code? Yeah, someone in the. Okay, great. So in this very short snippet of code, this is what I have a wrapper. In a package, there is a run wrapper that runs things. It logs also, it does something, so you can see, but it's basically a wrapper. So initially it used this. So there is a command, it can be a shell command or like a direct command invocation through system. You tell how do you want to handle standard input, output, and error, and the environmental variables. You can pass few more things, but that's most of the like important options. Then you call on the resulting object, you call communicate function, and you can optionally pass input. I use this because I invoke some tools, and then I want them to process a file, so I just pipe the input. So I could do that with the good old popen. Okay, but evolution never stops. Whoa. And then, in Python 3.5, subprocess run was introduced. So this is exactly what I was writing for like 4 years in a package wrapper, so they implemented it better, of course, slightly better. So I was very happy. So this is the new default way to run processes. It's a single command thing, because before you needed to create the object and then to call communicate. So now it's just a good simple. Oh no, these buttons are reversed. So now it's just one command. The returning object is completed process object instance, and this is very convenient. You can extract standard output, standard input, return code. So it's just like something like regular expression match returns. It's like an object that contains all the like attributes relevant to the result. So this was introduced in Python 3.5, and it's even usable since that version. It's maybe a little surprise. So after that, this is not working though. Yeah, so there is an honorable mention. SH library also did something similar like I did, because everyone needs it. Literally everyone who runs scripts or commands from Python needs this. So for me, it's a mystery how can it suck so much? How it was possible for this to suck so long and it still sucks. Do you understand me? So SH library was like an attempt to unsuck it a little. So you just import from the SH library, and this is like dynamic meta-programming fancy stuff, so it just creates a function for you that you can call with arguments, and it's the same as calling the command from your shell. So I considered using this, but it can't it can't do the thing that I want, that's printing standard output and input at the same time. So now the advent of Async.io. To be honest, I don't know anything about Async.io, or like very little. I'm a packager, so I'm a like jack of all trades. I know everything about, a little about everything, but so Async.io, I just recently learned where I needed to actually use it, so I was solving a real problem, that it includes these functions, yet again, introduced in Python 3.5. Safe to use since 3.6 on Debian 9, which is dying in a month, luckily. There is still Python 3.5, and when you do things, it raises such chain of exceptions. I never want to see that again. So don't use that before 3.6. But basically, all distros that support it are officially dead, so you shouldn't have to use Python 3.5 ever again, hopefully. So there are two functions. Async.io creates subprocess exec and creates subprocess shell. So in the subprocess run, there is an argument called shell. So this is like by default it is one function. Now that it's split, so it's like the first one is for shell false and the second one is for shell true. So these are split. Okay, I'll wait. So they have very similar signature to the subprocess run, and you can run this process asynchronously. So I said, maybe I could do a T with this. So let's see the official example for the Async.io, how to use it. So it's just few lines of code, should be simple, right? I mean, yeah, that signature is you just pass a command and some additional stuff. And then there is then you get the standard output and error. Yeah, that makes sense. I like that. So there is a library. Oh, it's doing interesting things. So there is a library called subprocess T. It's a drop-in alternative to subprocess run that captures the output while still printing it in the real time, just the way T does. Hey, I was not the only guy that wanted this basic functionality. Wow, someone actually did this. So this module is alright. I was looking at it, and it's even well packaged. You could actually use it even if you have like large distro support. You could actually use this without fear. This is largely available. But I was looking at the source code, and being the perfectionist I am, it doesn't pass the arguments directly. It is like a wrapper. So what I would do if I was writing the library, I would just like pass all the keyword arguments that I don't care about to the underlying function. It doesn't do that. It's so if you want to use some subprocess like the underlying arguments of the functions, you can pass it through this. So this is like one thing from actually being solution to what I wanted to do, but it's not. But maybe for you this could be a solution if you wanted this. So if you have a code that is using subprocess run, you just really change the import, and then the code is doing this. It can do T. So, but it's time to reinvent my own wheel. So there is a module in a package that just contains the function to run things, and then I had to add a large amount of code for what I considered a simple thing. So let's have a look at this. This function, if you just look at the signature, it takes arguments, so that's a command to run. Then whether it's a shell or not, shell command or like a direct command invocation, and keyword arguments. Oh no. And then there is the async IO part. So based on the shell argument, I just invoke one function or another. Notice that the arguments are different. All the methods to doing subprocess run and all the things I mentioned here, they have different like signatures. Sometimes you pass the command as a list of strings. Sometimes you pass it directly as arguments. It's a mess. There is no standard. So I made a wrapper that wraps all this mess into one thing. This is the async IO part. So I just like create the subprocess shell or a subprocess exec. Then I need to define an inline function which basically stores a line from the standard output to output. It stores it in a sync, and it also prints it. This is what I wanted. I would like for it to be just this one function. I would only show you these 4 lines and go home. But certainly it's not that simple. So this is the simple part. This function literally just stores the line and also prints it. And for a package, standard output is already used. You can pipe it. So I redirect both to standard error. So if you would want to, it would be one more argument if you would like to split them. So, some async IO code. So this, I stole this from the subprocess tree. I literally stole the entire code because we do open source and I can steal it without regret. And I don't understand why this is so long. Like the first line, like what kind of, wow, that's a long line. Okay, well, so now, if there is a request to capture or send standard output or error, I create async IO tasks using a function that takes a function. Interesting. So the readStream function I spared you, it's yet another function that basically awaits like a new line from the stream and then calls the callback function. Whoop, it's jumping. Okay, so finally I like from the sinks, from the lists of lines, I create the final strings for standard output and standard error, and I create the completed process instance. This is what subprocess run returns. So if you call this function, it returns the same thing as the like subprocess run would return. Oh no. Okay, so this was just the T function, and there is the runner, and now you can see in one like part of code the old way and the new way. So T if T is enabled, so that means I want to capture and print the standard pipes. So there is the new like async AO fancy way, again, very long line. Yeah, and then I call a function with just the arguments I collected. This is the difference why I had to write the code. No arguments parsing. When you are wrapping something, just like set the things in the thing you're wrapping and let it handle it. Don't create your layer of like crap on another layer of crap. Please don't do that. So that's why I had to write all this code for a trivial thing. In the bottom, you can see in the try, it's one function, subprocess run. All this code, these 4 slides I've shown you, are alternative to these lines. So this is the old, like currently default way to do this. And in Async.io, it was all this like code. But finally, after all of this, I can do very basic things. I can actually run thing and it will print, and I have the access. I actually added an extra convenience, so the result is actually a string subclass. So the result of the like running a command, you can compare it as a string, the standard output. So you don't have to, if you don't care about the rest, you can just treat it as a string. But if you care, you can check the written code, you can check the standard error. You can run shell commands, you can run commands as a list of arguments or like a directly passed list of arguments through Python function. So, this is unnecessarily complex. My point is, like running commands from the operating system where the code is being run is like the most basic thing. So I'm a language enthusiast. I like languages in general, and I have experimented with like 50 plus programming languages. Some of them were esoteric, like developers. Do you remember it? The brain fart variant. Yeah. So each of those languages that were not completely esoteric struggles with this, and I wonder why. Because if I would be creating a language, I would say, yeah, okay, but there are not libraries for everything yet. So maybe people are going to want to run commands from their operating system. But so in the end, it's about 200 lines of Python code to actually do this properly. The very basic, that should be the part of standard library. But getting there, maybe in Python 4. All right, and that's it. Thank you for your attention on my end.
Now it's question time. Do we have any questions?
Yeah, hit me.
Just one tiny question.
Yeah.
Because we implemented, this guy implemented exactly the same thing 2 weeks ago.
Nice.
What is the license of your library? Maybe still some code from it.
Yeah, please steal it. I can relicense it for you for any like open source license if you want. It's GPL, I think, but I can relicense it as MIT. It's no problem. Also, I stole it from the subprocess T. So like steal it from there. Mine is just, you can look at mine, steal it from there, you know.
Okay. Actually, our implementation like kind of close to yours, but maybe there is a couple.
Yeah, I've dropped few lines. I have why I didn't like use the existing 1.1 point for that. Why I chose to reinvent the wheel, which is always bad, like by a priori. So. How to say it? Well, one thing is I wanted to pass these arguments nicely. I don't see the reason why to put a list. That's one thing, and then I wanted logging. So when I run a package, if it was my computer, I could show you. But there will be presentation by me about a package in the future. So if you are interested in more than think about how everything sucks, I can deliver. So when you run a command, it prints, there is the way the package prints, and it goes to standard error with some mark that it's like from it, there is like a marking, and by default it shows you the command run. So when you look at the logs, you directly see the commands that your tool is invoking, which is useful when you're debugging. So, and I use, there is shell X, like it's a parser of shell expressions, and you can escape it in a way so that you just copy like the output, paste it into your terminal, and it's literally what happened in the background. So when you have like wrappers or libraries, for example, some Git libraries wrapping Git, so they try to give you a good interface. But in the end, it was like a Git command that failed, and you don't see the command that failed. So you're like, you know, you have, instead of like having one error and the command, you have 2 errors and no command. It's like a downgrade. I was actually thinking about maybe trying to, because the author of the subprocess T, I think he was looking for commentators, so I'm not sure he is very enthusiastic about continuing development. But I was actually thinking about fixing it, because it's so close to, the subprocess T is so close to actually being good. But with this example. Oh yeah, one more thing I forget. When I pass the input through the subprocess communicate, so that's when you set the standard input as a pipe, then through this argument you can pass to the pipe some input, a string. So with the async IO version, I didn't figure out how to do this. I'm enabled with the subprocess IO wrappers, I'm enabled to pass input to the input pipe. And when I try to create a mock object, it was looking for file descriptor. So it's not as easy. So maybe that's a lost functionality, like only one that was like lost from the old like subprocess, you know, subprocess run to the new async IO thing. So there was some lost in the translation, because subprocess run takes the input. The subprocess communicate takes the input argument, but none of these async IO take the input argument. So I don't yet know how to do it, and in the code I have shared. If it's this case, just don't do this, use the old version. So there are these like small reasons to actually write your own wrapper. If you're writing like a serious application or like library, where like logging is important, or this, which is always this is important, how the errors show to the users, there are reasons to still write your own wrapper through this. I dream of a world when you use the basic, when you just import from some library and do it. That's the Python, like you just import things and that's it. There's not supposed to be any programming.
Yeah, the most problem for me was like I need to modify like what I am getting like to the output, because like there is a build system called Ninja.
Oh yeah.
Sadly, Ninja lost.
That's just the result.
Yeah, I feel your pain, because when I capture stuff from Ninja, they disable smart terminal features. And instead of like progression, like when you build something, it's with one line, you close completely and you like getting a lot of text. And I need to like I mimicate what Ninja do in Python. Like I wrote all this smart terminal feature by hand. Like
wow, that's horrible.
Yes. Nice. And yeah, I opened the thread on Ninja and like, please give me a flag for this to force smart terminal, please.
I didn't know, I will meet this sooner or later, so thanks for the heads up. Because I'm using it from packages, and packaging software that's using Ninja, and it's relatively painless. Like, not horrible.
So do you have any other parts of the Python you would like to rewrite?
That's for a very long answer, like, are you sure you want to?
Don't.
Yes.
I know him.
Any other parts? Well, so if you want a meta answer without renting, so I was starting with Ruby, or like actually even more obscure languages. But for example, Lisp, I'm very sorry that Lisp didn't make it.
Come on, it's still an Emacs.
Yeah, but as its author said, Lisp doesn't seem any deader to me today than usual. So I was starting with Ruby, and while many things about the language suck, do you know why Python won against the Ruby, by the way? Do you know why it won the race? It's, in my humble opinion, it's because Ruby, the metaprogramming in it was so easy, so like really available, that people actually used it and they created their own DSLs, their own like languages. For example, Ruby on Rails it's like a language. You know, Perl, do you know what can parse Perl? There is only one thing that can properly parse Perl, and that's Perl interpreter. There is no other thing that can do it. And with Python, libraries are just like black boxes, and they try to be idiomatic, and they try to be reusable, and just you can combine them. You want to do like 37 different things. Okay, download 37 Python libraries, put them together, and they're gonna work. In Ruby, everything was like a monolithic pile of crap with its own DSL. And yeah, okay, combine Ruby on Rails and any random other medium to big Ruby library and let me know how it was. It was a pain. You wanted to kill yourself probably. Only after like a week with that. So Ruby, but on the user side, Ruby was beautiful, and the object-oriented part of Ruby is like 2 tiers better than in Python. And in Python you can tell it is a functional language, or it tries to be. That's what was the origin. And then object-oriented programming was forced by the stupid masses. It always happens, yes? So object-oriented programming is a mistake, yes? In Python, they were right, they didn't put it, but people already were indoctrinated to use it, yeah? So they forced the authors to include it. And everything in Python, that sucks. It's mostly because object-oriented programming was forced to a language that was not from the start designed for that. And in Ruby, there is from the start, even in old versions, there was good object-oriented programming. For example, I was raging for Python super. Did you see the super function of Python 2.7? That's the most horrible thing I've probably seen. And it includes the esoteric languages like brainfuck, like nothing. And yeah, so objects, alright. So when you run a method, object function, it inherently, implicitly means that you're working on an object, so you will need a reference to that object. Do you agree with it? So in Python, wow, you need to actually pass the object as a first argument to all your methods. And yeah, I've seen why. The person who is responsible for this, they were like, why is this so horrible? Because it's horrible. And they were like, oh, and it was very long rant, well-written rant by an intelligent person about how the implementation doesn't allow it, and he's not going to do it, and no one can. And nothing about it was why it shouldn't be like that. It was just like, no, it would be too hard to change, and it's like, no, there is no good reason for this. There are many things in Python that are real bad, even that are better in languages that are 20 years old. So I could rant about this for a very long time. Python 3, I hoped it would fix more things. I paid the price in blood for the transition, for all the Python 3 packages. And in Fedora, don't get me started on it, it was really horrible. So for this price, I paid with my blood. I hope they would fix more things. Sorry for the very long answer, but it's your responsibility.
Please another talk for next hour out of it.
Yeah.
For the sake of moving on and networking and beer, let's more questions that can come out.
Yeah, does anyone dare asking another question after this?
Sure. Well, this was the rent-free version, you said, right?
Sorry?
This was the rent-free version, you said, right?
Yeah, and then I failed at doing that. I tried so hard to.
You got so far?
That's the part when I didn't pick particular horrible things you meet every day. But you know all of this. So.
I don't actually package anything, thankfully, so no.
Oh, sorry.
I don't package anything, so no.
Oh yeah, well, Python packaging is alright. Do you know what sucks? Rust packaging. If you get a Rust package, every Rust package into Debian, I will buy you a nearly unlimited amount of beers. Out of pure respect for the alpha packaging skills.
So we're slowly slipping into networking and probably to the point where we can end the questioning line.
Don't get him started on networking.
Out of pure curiosity, does anyone have a lightning talk here?
This was supposed to be a lightning talk initially.
We messed up somewhere in how we start. So probably you can stop here. And thank you very much for great.